Hello everyone. My name is Yufeng, and my lecture is Construction Method of Fire Emergency Rescue Communication Network based on Mixed Organization and Self-Organization. Part 1. Abstract. Other article first discusses the severe situation of the emergency communication requirements of the fire rescue team at the emergency rescue site, and then analyzes the current situation and existing problems of the current fire emergency rescue communication network. In response to the problem, a fire emergency communication network, based on a mixture of other organizations and self-organizations, is proposed, and the network structure, construction method, networking process and network status change rules are elaborated in detail. Finally, the Fire Emergency Communication Network construction method, constructed in t'other paper, is compared with the traditional Emergency Communication Network construction method. Part 2. Introduction. Since 2010, high-rise buildings, super high-rise buildings, urban complexes, and large underground spaces in Chinese cities have shown a trend of blowout growth. According to the statistics of the World Society for Tall Buildings and Urban Habitat (CTBUH), China has has the largest number of completed high-rise buildings of 200 meters and above each year. In 2016, 84 buildings accounted for 67% of the world's total completed construction. According to statistics by the China Real Estate Information Group (CRIC), at the end of 2013, 220 new urban complexes were added to 21 key commercial cities in my country, with an additional supply area of 154.79 million square meters. The urban complex development volume has a trend towards second-tier cities in the central and western regions. Such a large building has brought tremendous pressure for firefighting and rescue operations to the firefighting team. According to the statistics of Professor Fin Mayo Kui and others in the article Research on Injuries and Deaths of Firefighters in Firefighting and Rescue in My Country, during the period of 2005 to 2013, there were 70 firefighters' casualties in firefighting and rescue in China, resulting in 85 firefighters' deaths and 163 injuries. Among the direct causes of so many firefighter casualties, building collapse accounted for 46% of all casualties. In response to t'other situation, how to ensure the life safety of firefighters in firefighting and rescue operations has been a key research topic in the field of firefighting and rescue for a long time. As a comprehensive research topic, the life safety protection of firefighters involves multiple disciplines such as personal protective equipment, firefighting and rescue professional training, risk assessment, etc. And as one of the important supporting technologies, rescue site emergency communication technology plays a very important role in the rescue process. First, if the emergency communication network inside and outside the building can be kept unblocked, then the firefighter can get in touch with the external commander and the internal combatants during the rescue process. And if they are in distress or other people are in distress, they can request internal and external reinforcements. Second, it can also transmit internal on-site information to the outside through the on-site emergency communication network, including personal's location, vital signs monitoring data, internal environment temperature, fire gas conditions, etc. For external commanders, t'other information is used as an important decision-making basis for the next rescue operation. Modeling based on these dynamic data can evaluate the burning state of the building. Once it is judged that the building is at risk of collapse, it can issue evacuation orders in time through the emergency communication network to prevent casualties. Part 3. Research status. In order to solve the problem of emergency communication guarantee for building firefighting and rescue scenes, the fire brigade has conducted various technical attempts and explorations since the 10th five-year plan period. A series of scientific research results have been achieved. which can basically guarantee the emergency communication support requirements of building firefighting and rescue scenes. However, some construction sites, such as super high-rise buildings, large underground spaces, and urban complexes are still slightly inadequate, and it is difficult to meet the comprehensive emergency communication guarantee needs of such buildings. The communication guarantee feature of building firefighting and rescue scenes lies in the emergency feature. Traditional fixed deployed communication facilities cannot meet the emergency feature. When a disaster accident occurs in such a place, in order to avoid secondary disasters, it is often necessary to disconnect the mains at the first time, which leads to the failure of the indoor antenna feeder system of the public mobile communication network inside the building. Therefore, in order to meet the emergency characteristics, the emergency communication guarantee for such places should be deployed temporarily, and the deployment process should be simple and convenient. Another difficulty in the emergency communication guarantee for building firefighting and rescue scenes is that the space structure in the building is complex, and the radio frequency signal will be reflected, refracted, absorbed, and attenuated during the propagation of the internal space. T'other has a greater impact on wireless signal coverage in indoor spaces. During the deployment of the indoor antenna feeder system, the indoor wireless signal coverage drive test software can be used for planning and deployment, but it is difficult for the fire brigade to deploy temporarily. The outstanding feature of building firefighting and rescue on-site emergency communication guarantee is that the construction or deployment of on-site emergency communication guarantee network is not accomplished overnight, and the scale of the network is gradually adjusted dynamically with the advancement of firefighting and rescue missions. Therefore, T'other puts forward higher requirements for the flexibility and convenience of network construction and deployment. Based on the above, T'other article proposes a method for constructing a fire emergency rescue communication network based on a mixture of other organizations and self-organizations. The other organization theory method is used to establish the backbone link of the emergency rescue communication network. The backbone link bandwidth is constant, and the bandwidth loss due to data transmission hop between points is avoided. The self-organization theory method is used to establish the emergency rescue communication network branch link, and the bandwidth of the branch link is automatically adjusted with the increase of hops to expand the coverage of the emergency rescue communication network. EART4. Network structure. The structure diagram of the fire emergency rescue communication network, based on the combination of other organizations and self-organization, is shown in Figure 1 below. The fire emergency rescue communication network, based on the combination of other organization and self-organization, consists of several other organizations and self-organized relay devices. Other organized relay devices are used to deploy the backbone of the fire emergency rescue communication network, and self-organized relay devices are used to deploy an extended network of the fire emergency rescue communication network. Different from the traditional wireless emergency communication network, in the fire emergency rescue communication network, there can be more than one other organization network communication link, and there can also be more than one self-organizing network link. But the basic principle is that, in the entire network, any other organization relay device can only be connected to one self-organizing relay device or not to any self-organizing relay device. Fig 2. Schematic diagram of fire emergency rescue communication network application, based on the combination of other organizations and self-organizations. The mobile communication command center of the fire rescue team deploys a server to store global parameters, including RE, OORE, SORE, and flag. Although both other organization and self-organizing networking methods belong to non-centered networking methods, due to the particularity of the fire emergency rescue communication field business, there needs to be an applied transfer center. The purpose of the server in t'other article is to store the dynamic parameter information of the networking process, which overlaps with the emergency communication command business of the fire rescue team in application. So it is not an additional configuration and will not increase the networking cost. PART5. Networking process. Fig 3. Flowchart of fire emergency rescue communication network based on the combination of other organization and self-organization. PART6. Status changes. Fig 4. Initial state of the network. Fig 5. End state of networking. PART7. Conclusion. The hybrid organization networking method proposed in this paper can maximize the use of limited bandwidth in terms of link bandwidth usage and control. Applying other organization networking method to realize the construction of the backbone network of the emergency communication network in the fire emergency rescue site. It can realize the wireless relay of data in the air under the premise that the network bandwidth of the backbone network is not damaged. The self-organizing networking method is used to establish an extension network of the emergency communication network in the fire emergency rescue site to realize the automatic extension of the emergency communication network and increase the coverage of the network. Compared with the traditional other organization networking method, the hybrid organization networking method proposed in this paper is more flexible. On the one hand, this method avoids the prominent application problems of network congestion and network delay caused by the excessive flexibility of the self-organizing network method. On the other hand, this method introduces the other organization networking method in the self-organization method and transfers the construction of key nodes or backbone networks to the other organization method and realizes the other organization network construction through the automatic control method. On the basis of not reducing the flexibility of network construction, the deployment and construction of other organizations' networks are realized, and the integration of self-organization and other organizations' networks is also realized.